Okay, welcome to the Hard-Surface Handbook. This is Josh on this recording, and in this video we're going to discuss Auto Smooth. Now, Auto Smooth is a super important functionality in hard surface modeling, and we can pretty much knock out what it does in just a few minutes here. So what I have is a default cube in the scene, nothing special. Now if I right-click and choose Shade Smooth, watch what happens. The shading goes absolutely ballistic, it's no good. The reason this is happening is because it's trying to smooth over a very harsh angle here. If you try to smooth over a 90-degree angle, it's just not going to look very good. But, for example, if I had a big bevel here, actually, as a matter of fact, if I just beveled the whole thing, you're going to see it smooths out a lot nicer because we have a much more rounder surface to smooth over. So, yeah, with that in mind, that's basically why the shading turns terrible. This angle is just too harsh to smooth over, so the shading doesn't look very good. So oftentimes we need to tell Blender, hey, I don't want you to smooth this area because of its angle. And Auto Smooth does this specifically. So if we go to this green triangle panel under Normals and tick on Auto Smooth, this is only going to smooth based off of this angle. And basically what Blender is saying is, okay, anything above 30 degrees, I do not want you to smooth out. And as you can see, this cube is only consisting of 90-degree angles, so since 90 degrees is above 30 degrees, Blender's saying, okay, since we're above this angle, we're not going to smooth it out. Now anything below 30 degrees will be smooth, and I can demonstrate this here. If I were to bevel this, or if I did a chamfer, it's going to be at 45. So if I do another bevel, it's going to be at half of that, which is 22.5. So if we pull that up, you're going to see this area will be smoothed because this angle right here at these edges are below the 30-degree threshold. Now, truth be told, most of the time you don't need to worry about the angles and do any sort of calculations. 99% of the time, all I do is I drag the angle until it looks good, and that's usually all you're going to have to do. And you're going to see in this case, right when it hits 45, because this is a 45-degree angle apparently, that is when it starts smoothing out. So this is a good example here. So maybe I'll just go above 45. So now what you're going to see is, okay, Blender's saying anything below this 48.2 degrees, I want you to smooth out. So it looks like this bevel is getting smoothed out. But anything above that, I do not want you to smooth out. And since the rest are all harsh 90-degree angles, Blender is not smoothing those. And as you may have guessed, if we go to 90 degrees, what's going to happen? The shading is going to get terrible. So right when we go above 90 degrees, shading goes crazy because now it's smoothing over those 90-degree angles. So that's no good. But like I said, most of the time 30 degrees works pretty well. And you don't really have to worry about calculating anything. You can just kind of go around and adjust this manually. So here's a little bit of a more specific example. What I'm going to do is just select this and remove this bevel modifier. This is just a little project I was working on not too long ago. So if we go to the Auto Smooth functionality here, you're going to see it looks like 30 degrees smoothed out everything pretty nicely. But if this was at anything different, sometimes it'll get jagged, or if it's too high, then sometimes the shading will just go crazy. So like I said, don't worry about the angles and all the calculations. Literally, just take the angle and drag it until it looks like it should. So in this case, it looks like it's around 30 degrees, works pretty well. And that's basically the Auto Smooth functionality, so you don't have to stress too much about it. It's super simple and allows you to smooth based off of angles in your geometry. Okay, welcome back. So this video is going to discuss arguably the most important modifier in all of hard surface modeling, and it is the bevel modifier. So before we even go over the bevel modifier, I want to showcase some artworks that I really enjoy and how exactly these artists use bevels in their work. So here's a real-world example with Boston Dynamics. You've probably seen their robots before. Crazy cool. And you can see nearly every area on their mesh, actually not nearly, literally every area on their mesh has some form of a bevel on it. You can zoom in here, you can see that nice rounded area. There's a nice little bevel there, even on the front. Literally everywhere there's a bevel, and as a matter of fact, no real-world object can exist without a bevel. Even a piece of paper, if you zoomed in far enough microscopically, you'd eventually be able to see a little bevel on the edge of the paper. Nothing is perfectly sharp, so that's one reason we add bevels. Another reason we add bevels is to capture edge reflection. So here's a little turntable model I created for one of my courses, and if we really zoom in here, you can see, for example, there's a bevel where this little capsule is. If we zoom in, you can see that there's a nice amount of light kind of captured and reflecting off the edge there. Same for over here. Pretty much everywhere there's a bevel, there's some form of light reflecting off of it. Now, if this was perfectly sharp, you wouldn't see that light reflection at all, and it would just look dull and boring, and something would seem off. I'll quickly go through some of my other favorite pieces of art. So here's one by one of my favorite artists, Idon Grazio. I'm pretty sure I pronounced his name correctly. He's a fantastic artist. You can follow him on ArtStation. Here's an example of one of his works, and you can see he incorporates bevels very nicely in his models. Here is one of Ryu's models. You can follow him on ArtStation as well. You can see all of this here has a nice bevel. This was actually made in Blender, as a matter of fact. All the areas have a nice little bevel on it capturing the light. You can especially see it here. This bevel has some nice light reflection, so it's super important for that nice little design. We can go down here, you can see another one of his models. Bevels basically everywhere. And then we'll just go to a few more of my favorites. So here's another fantastic work by Vitaly Bulgarov. You've probably seen his work before. He's an absolutely amazing artist, one I look up to very heavily, and you can see in his models he also has bevels all added in there. So you can definitely check out some of his work to see more of that. Here's another one of Ryu's models, bevels everywhere. And then another one of my favorite artists, Ivan Santic. He has some really cool concept and military type designs that have a lot of bevels inside of them as well. Anyways, at this point, I think you get the memo as to why bevels are important. So I want to quickly demonstrate what it looks like with a bevel and what it looks like without a bevel, because it might not seem like it's that important, but you'll see once I turn it off how important it is. So here's one of my more basic models here. You can see there's bevels pretty much over all the edges. So if I select this and turn off the bevel modifier, look at that. Looks absolutely terrible. And you can't quite tell what it is, but I can pretty much point out exactly what it is. If you take a look, once the bevel hits, we get all of these nice light reflections, especially right here. You can see a very defined light reflection versus if it was turned off, there's no light reflection. So you can really see the difference in how much it really starts to pull out your models. Anyways, now that we understand why we need bevels in our hard surface models, we can go ahead and go over a little bit of the bevel modifier. So I'm going to go to Add Modifier, add a bevel, and you're going to see that we have this offset option that simply allows us to increase the bevel or decrease it. Most of the time in hard surface, you only need a very slight bevel. There's no need to go crazy high. And then usually I'll have like 3 or 5 segments. I usually keep it at an odd number for no particular reason. So yeah, 3 to 5 segments is usually plenty, because once you go any higher, it doesn't make a huge difference in terms of shading. So yeah, I'll usually do around 5 segments, a very tight offset, just enough to capture the light. And then of course we also have to shade smooth and turn on our auto smoothing. So you can see how nice this already makes the cube look. You can see if I turn it off and back on, looks pretty decent. Another thing we sometimes turn on is harden normals or use a weighted normal. We'll have a separate video on that, but basically it just makes the shading look better as a very generic explanation. Now we also have the bevel profile. This either makes things concave or convex. You can take a look here. That's convex, and at a value of 0 is a concave bevel. I rarely adjust the profile. I usually leave it at 0.5 or maybe a little bit higher. Now we also have this thing here called a miter type. This is super important and practical. Actually, a lot of people overlook this, including myself. For many months I never really messed with these, but they're actually super useful. So if I were to add in a cut right here, for example, I'm just using box cutter once again, and maybe I'll just I don't know, tighten the offset a little bit. It doesn't have to be that big of a bevel. But if you go into the corners here, you can really see it's a very defined triangle. It's kind of pinching. And that's because the outer miter type is set to sharp. Usually we can change this to something like patch or even arc. And if sometimes the shading goes bad, you can turn on harden normals to clean that up. So you can see what patch does. My personal favorite is arc. You can see that kind of rounds out the area. It looks a lot nicer. So if you were to choose between the sharp or the arc, I think the arc looks way better. And you can also go into wireframe here and see how it's working topology wise. If I were to change this to sharp, you can see how that kind of pinches. There's patch, which kind of has more of an extension in the back, and then there's arc, which just has a very nice seamless transition between these two edges. As for inner miter type, I honestly never touched that, so I don't really have a practical use for it. I don't think I've ever had to change this to anything, and if you do, it just looks sloppy. You really only have to worry about the outer miter type, that's the main one. Now, limit method is an important one, and I've added in a cut here, just a simple cylinder cut, and you're going to see that literally every single edge in here is being beveled. It's very, very clear and apparent. So basically, if we change the limit method to angle, you're going to see it gets rid of that problem. So with the angle limit method, only adjacent faces that have an angle smaller than this value are going to be beveled. So that's basically how that's working. So you can see if I really drop this low, then those bevels on the ridges will come back, which is not what we want. But it looks like the default 30 degrees kind of captured everything just fine. So now we have a very smooth roundedness in here with no sort of weird bevel issue like that. Now I'd say somewhere around 70 to 80% of the time I use the angle limit method, and pretty much the rest of the time I use the weight limit method. We'll get into bevel weights later on in this handbook, but basically you're also allowed to bevel based off of your selected edges. So if I were to change this to weight, for example, nothing's going to be beveled because we haven't selected what we want to have beveled. But for example, I'll go ahead and apply these booleans here. So say I went in here and selected all these edges. We'll just do it for the cutters, and then I also went in here and selected these edges. If you press the N key and then go to item and increase the mean bevel weight, you're going to see it slowly starts marking these edges, and a value of 1 is a full bevel, and you're going to see that is affected because of our limit method being set to weight. And meanwhile, everything else will not be beveled because we haven't marked those edges yet, but if we do, you can see those get nicely beveled. And there's all sorts of ways to stack bevels and get different levels of bevels. For example, here I could reduce the mean bevel weight and have a much tinier one than I have over here. There's a lot of different things you could do, really. Most of the time, if you want to have different levels of bevels, you either adjust the mean bevel weight, or you can also use something called a step bevel. It's a little bit out of the focus of this course, but that's basically how the bevel modifier works in a nutshell. Now you also have the option to mark certain areas with seams, and usually you use seams for unwrapping. In hard surface, most of the time you actually use seams to have different areas of selection. Let me demonstrate. So if I were to mark a seam manually around the entire top set of edges, I'll press Ctrl E and then mark seam. Check this out. If I try to select these upper faces, I don't want to have to do it manually. I can just press L and select the linked faces, and it will select everything encapsulated in this seam. Same for the bottom. You can see it's physically separate while being its own entire object. And also, if I remove the seam and then I try to select with the L key, it ends up selecting everything. So you can actually use this to separate physical areas of the geo. I don't usually have this on too much, but if there's a time I kind of want to isolate the edges I'm marking, then sometimes I'll tick on mark seams. Don't really stress about it too much. You'll run into a situation where you may need it or you may not need it. You also have the option to mark sharp based on the bevel if you want to do that. We've already done a video on the sharp options, so yeah, you also have the option to do that with the bevel modifier as well. Now sometimes to keep things constrained, especially if you're using subsurf to increase mesh density, you'll usually want to use the mark crease option, and unfortunately that's not included with the bevel modifier by default. But if you have hard ops, you can actually just go to the Control tilde menu and turn that on manually. You can apply creases with your bevels as well, if that's something you want to do. And while we're on that topic, let's quickly discuss why an add-on like hard ops can help us with beveling, because vanilla just doesn't cut it sometimes. So if I want to bevel this cube, this is just the default cube, nothing on it. In Vanilla Blender, you have to go to Add Modifier, Bevel, Segments up to 5, or whatever you want. You have to shade it smooth, then you have to adjust the offset, and then you have to turn on Auto Smooth, and then go back here to Harden Normals to clean up the shading, or you could also use a weighted normal, basically the same thing. You'd have to tick on that, and then finally you'd have to change the limit method to an angle, just to, angle, weight, whatever you're using. And how many different steps with that, like 5 or 6, and you can see how tedious that will really get, especially if you're using bevels a lot. But in hard ops, for example, it does all of this for you by default. So if I just start a completely new scene here, literally nothing in it, we'll just add a new cube. So by default, we don't have auto smooth on or anything, we don't have bevel, we have nothing. In hard ops, if you press Q, you can hop right into the bevel. Done. Completely finished. You're going to see auto smooth is turned on. You can adjust the angle. It was on 60 by default there, which I think is fine. So yeah, auto smooth is turned on by default. It sets the limit method to angle. It sets the segments appropriately, which you can also adjust. You can just scroll up or down. And then offset, super easy because I don't have to drag in here. I can just pull the mouse forward or backwards like this. And you can adjust all the same settings in the bevel modifier with hard ops. You can literally increase your scroll wheel to get more of a bevel. You can adjust the limit method. You can adjust the angle. You can do everything with just a few keyboard clicks in hard ops. So that's why add-ons like these are just a lot better to use and will really improve your workflow. And commonly in hard surface modeling, you'll be stacking booleans with bevels all the time. And the nice thing about hard ops is if I add in a cut, for example, not only does it sort it in the modifier stack by putting it above the bevel, because if we swapped them, that's no good. By default in Blender, you'd have to manage the modifier stack manually, but hard ops does it automatically for you. So whenever you add in a boolean cut, you don't have to stress about the stack. It puts it right where it should go, and you can see how nicely it adds in little bevel cuts for you. So you can really begin to see how useful the bevel modifier is and how you can start stacking this with other modifiers to get really cool designs, much like the ones we use in hard surface all the time. You can kind of adjust the offset whenever you need to. You can do everything you need to do with just a few simple boolean cuts and bevels. Alright, welcome back everyone. Josh on this one. So we're going to discuss the boolean modifier. So most of you know how the boolean modifier works, but we'll still do a pretty quick overview to get everyone accustomed just in case. So if I add in a cube here, and I add in another cube, I'll just duplicate this one with Shift D, scale it down, and move it over. You can actually slice objects out of a base object, kind of like this. So if you took this and basically used this as a slicer from this cube, then the area that's being shared by the two would be removed. So if I select the base object, we'll go to the modifier panel, choose boolean, and then pick this one as the difference. You're going to see that you can kind of see the outline. If I undo and redo, you can see it's actually getting cut out. Now what you either have to do is you have to change this to the wire view here under viewport display. You change this to either wire, or you could do bounds as well, and then you'll be able to see the cut. Or if you want to go destructive, you can apply this and then that geometry will be locked in. But if you don't apply that, then obviously it'll be non-destructive, meaning you won't have access to the geo, but you'll be able to move this at any point in time. Now everyone has their own unique approach, and it's unfair to say which way is best for every situation because it's really subjective and depends what you're doing. But for the most part, I prefer to do it this way, where I have this set to a wired view and I leave it non-destructive so I can change this at any point in time. Now, as you go through modeling, there's of course going to be times you need to go destructive and apply your booleans, but most of the time it's a better idea to just leave it like this and only apply it when you have to. Now you can also do this with any other object really. Perhaps I'll do it with a cylinder, so I'll add in a cylinder. Make sure that's at 32 or 64, whatever you want to put the vertex count at. I'll leave it at 32. Scale it down and then move it up, and then we'll just go to the cube here. And the boolean's red because we deleted that original boolean cut, but we can just choose a new one here. Pick the cylinder, and then if we change this to wired view, you're going to see that we have a pretty nice cut here on the top, which we can adjust to our liking. The issue with booleans and curved surfaces is that they produce the stepping issue, meaning you can see these little ridges in the mesh here. So obviously to fix that, you can simply smooth out the object. So if I right click and then shade smooth, the shading is going to go crazy, but in the auto smooth video you already understood why this is and how to fix it. So we simply need to turn on auto smooth, and that default 30-degree angle will be just fine. But you're going to also notice that the inside unfortunately didn't get captured by the smoothing, and that's because we also need to shade smooth our cutter object. If we select it and then shade it smooth, that will be fixed. Now you don't have to enable auto smooth for your cutter objects. I just usually like to for good measure. It's not going to make a difference in this case, but it's always good to turn on auto smooth because you're pretty much always going to use it. And that's basically how you can clean up ridges on curved surfaces that you use as a boolean cutout. Now obviously it's really tedious to have to go to your base object, add a boolean modifier, pick your boolean object, and then go to the Boolean object and then switch that to bounds view and then smooth everything out. That's a ton of different steps, and if you have a lot of Boolean cuts, that can simply take you forever. And we can demonstrate this in just one swift go. I'm just going to start from scratch. We'll delete the cutter, delete the Boolean. We just have a simple cube. And I'll also shade it back flat and turn off auto smooth. So we're just completely reset back to the default cube. So if I were to do this the vanilla way, I'd have to go in, add the cutter, maybe we'll do a cylinder, put it into the place, whatever place I want to add it in, and then I'd have to go to the cube, add a Boolean modifier, pick this guy, then go to the cutter, change it to bounds, and then smooth this out, turn on auto smooth, and then smooth this guy out. That is a ton of different steps all to get one cut, and when you do a lot of hard surface modeling, you're going to have hundreds of cuts, so you can see how tedious this could get after a while. And this is where add-ons like Hard-Ops and Box Cutter come into play, because it does all of this in one swift motion. Let me demonstrate. So I'll just delete everything out of the scene. We'll start from scratch. So you just saw the process that I needed to go through to get a cylindrical cut in the top. No fun at all. But if I use the Box Cutter add-on, let me turn it on here, we have the circle option. I can literally go in here, I can turn on snapping, hold control, check this out. Done. One click, it did everything. It changed the view, it smoothed everything out, it applied the Boolean, it did everything we need to do, but saved us a ton of time. And another thing that's nice about Box Cutter is that it also hides your cutter once you're done with it, which you can quickly access in hops via mod scroll. So you can always get back to that whenever you need to. So it simply makes no sense to continue on the vanilla route if you're already accustomed. So once you're familiar with vanilla Blender, it's definitely a good idea to grab an add-on like Hard-Ops or Box Cutter to speed these processes up. Now we also have different Boolean options, which I can quickly demonstrate. Most of you probably know what it is. So I'll do it in vanilla. So say I add in another cube here, we'll add a Boolean. So we have two more operations here. We have intersect and we have union. So intersect is going to take the common area between the two objects, whatever is being shared. So basically in here, you'll see in a second. So if I change this to intersect and then choose this guy, you're going to see we get that common area there. So that's what intersect does. And then union simply fuses the two together. If I change that to union, this fuses the two together like this. And I also have a video on my YouTube about the different Boolean operations if you want to watch more into that, but they're pretty obvious as to what they do. Now there are actually several more Boolean operations that you can't see in here. And the trick to get those is to use a combination of Booleans between the cutter and the base mesh with various different operations. Usually this can get very complex really quick, and I don't even know how to do most of them in vanilla Blender. So this is where add-ons come in handy because of how tedious some of these different Boolean operations can be. Let me demonstrate. So with the Box Cutter add-on, I'm going to choose box and then cut through. So I can cut through, and by default it gives you a difference Boolean, but there's also a ton of different operations that you have access to. One of them is the slice operation. If we go through here, this basically slices the object like that. This is good to get nice visible seams and little bevels in between areas. I use this one most of the time when I'm doing hard surface. You also have another one here. If I undo this, you also have the inset Boolean. This is another one of my favorites. This one's actually super complex to do in vanilla. I would not even recommend doing it, but fortunately with Box Cutter we can just do it in one go. So I'm just gonna cut through here, and you can see exactly what that does. So on the base mesh it adds in a simple difference Boolean, but if we bring the cutter back in, what we also have here is a solidify and another Boolean with intersect, and you can see that it does all of this for us. We don't have to deal with adding in a bunch of different Booleans in vanilla Blender. And we can also adjust the inset operation here with the solidify modifier, as you can see. So this is a very useful tool to use in Box Cutter that you don't really have available to you in vanilla without a ton of work. Let's see what else we have. We'll just undo this, bring it back to where it was. Now we also have the join. This is just a union. We have the knife, which basically just cuts a knife. And then we also have extract, which is a little bit more advanced with the Box Cutter. It allows you to take custom shapes as Booleans. We won't get into that. So yeah, by default in Blender, you have the difference Boolean, the intersect bool, and the union Boolean. But if you have add-ons, you can actually get other Booleans such as inset, outset, and slicing. I'm not going to go into a ton of detail with those are just ones you have to experiment with. And also, by the way, if you don't have Hard-Ops or Box Cutter, you can easily substitute this with the Bool Tool add-on. There is just way less functionality with Bool Tool, so I would only really use this until you're able to get the add-ons. So that's also another option that kind of helps do everything automatically for you. Anyways, I think we discussed everything with the Boolean modifier. It basically allows you to cut shapes, join shapes, and take similar areas between two shapes. And Booleans are a fundamental operation in hard surface modeling, so make sure you get accustomed to using them. Alright everyone, Josh on this video. I want to discuss non-destructive versus destructive modeling. Now it's a pretty simple concept and we're going to demonstrate it right now. We'll use a cube as usual. Maybe turn on the screencast key so you can see what I'm pressing. This add-on is super buggy. Hopefully it gets fixed soon. Okay, anyways, basic cube as usual. So I'm going to use the box cutter add-on just to make these Boolean cuts a little bit quicker. So I'm just going to cut through here. Just add a few different ones, nothing crazy. Maybe add in one more with a circle. Okay, so what we have here are a few different Boolean cuts. You can see we have 4 different Booleans for all 4 of these cuts. Now, if you're using Hard-Ops, you also see this option up here called destructive and non-destructive, and by default it's on non-destructive. So if we type into edit mode, you're going to see that we don't have access to any of the underlying geometry that we see here in object mode. And that's because although these Booleans are here visually, they're not there on the geometry level, and they actually won't ever show up until we apply the Booleans over here in the modifier stack. So right now we're working non-destructively, and this is super useful because I can adjust the position of these Booleans at any point in time. So say maybe I wanted to move this corner a little bit, I could just go to mod scroll and find my Boolean cut, and you know, I could readjust it, maybe scale it, and then just hide it. So since we're working non-destructively, it's super easy to be more versatile and move things around. Okay, so what will happen if we apply all these Booleans? Or actually, you know what, let's go ahead and apply maybe just the corner one, and we'll leave the other ones for better demo purposes. So which one was the one for the corner? It looks like it was cutter 001. So I'm going to apply this second Boolean here, and you can ignore that message since we're only working with bools here. So if we tap into edit mode, you're going to see that once we apply the modifier, this geo now becomes accessible. So now we've went destructive. We have quote-unquote destroyed the modifier here. It is gone, it's applied. But now the downside, not necessarily a downside, but the other side of things is that we now have access to this underlying geometry here. Now in more complex models, there's going to be times you have to go destructive. You absolutely need to apply the Booleans simply to access the underlying geometry, to maybe clean up the topology, or to fix shading issues. Whatever that may be, you're going to be going destructive all the time. But I personally don't like going destructive if I can avoid it. Reason being is because we don't really have a need to apply this Boolean here. It's not anything we have to really clean up or deal with any shading, so there wasn't really a point in applying it. So now if I want to move this Boolean anywhere else, it's a lot harder because now I have to go in here and select the geometry and maybe deselect this, and I just have to do all sorts of manual adjustments. And even still, it's not going to work as well as we would have expected because it's you can see how it's kind of pulling the geometry with it. We can't do as many changes as we were able to do with the Boolean. So in my opinion, if you don't have a reason to apply your Booleans, simply don't. It's just going to give you more headaches in the future and you're not going to be able to adjust things. And as you can see, these other guys, we don't really have a need to apply them. So if there's any point I want to go in here and make changes, I can just access the cutter and move it. I can go to really any of these and just move it around. And you can see at any point in time, I have the ability to change the positioning of these Boolean cuts. Now here's a prime example of when you might want to go destructive. You can see that we have a cylindrical cut in this curvature here. Produces really bad shading. And you can do a few things to kind of help isolate the geometry. You can perhaps go in here and add in some edge loops in edit mode and just kind of tighten up that geo. Maybe slide this a bit closer. You can kind of see that most of this shading, if I turn off wireframe, is now pretty constrained, but it's still very visible. So usually in situations like this, there's no real way to completely get rid of it without going destructive. So in an example like this, usually what I would do is I would just bite the bullet and then I would just apply the Boolean modifier and then really get in here and start cleaning things up. So, I could perhaps turn on auto merge and then just start kind of merging the near miss vertices, doing really whatever I can to kind of clean up the geo, because right now the geometry is yelling at us via shading and artifacts and things like that. So yeah, usually sometimes you just have to bite the bullet and go in here and just start cleaning things up manually. So, a situation like this, after a little bit of manual cleanup, you can fix the shading pretty easily, looks a lot nicer. And there's just simply no way I would have been able to do something like this had I not went destructive. So there are times you need to go destructive to clean up shading, to kind of make the topology more oriented, whatever that may be. But if you can avoid going destructive, I would definitely recommend doing that. And then, what I could do is drop in some extra box cuts here, and here I don't even need to go destructive. There's no reason to, because, it's not affecting the shading. There's nothing that really needs to be cleaned up, so I might as well leave it. So that's basically a quick overview of non-destructive versus destructive. It's a very simple concept, so if you understood everything in this video, you'll be good to go. What's up everyone, Josh on this video. We're going to talk about sharps and the mark sharp option specifically. So before I mentioned that if you want to, smooth this guy out but not have the smooth shading go crazy, you simply use the auto smooth option here. In this angle, anything below 30 degrees will be smoothed, anything above 30 degrees won't be smoothed. And since this whole cube is consistent of 90-degree angles, since 90 degrees is above 30, nothing's going to be smoothed out. So that's what the auto smooth is doing. Now, although the angle is what's controlling the smoothness of this guy, you can also do it manually using the mark sharps option. Now for this to work, you have to make sure auto smooth is turned on. So here what I did was I put this above 90 degrees. So now anything below this value will be smoothed, and since 90 degrees is below this 94.6 degrees, then everything is going to get smoothed and look crazy again. But I don't have to rely on auto smooth only. I can actually mark the areas I want to be sharp manually. So I'm just going to select the whole thing and mark this whole thing as sharp. I'll press Control E, not mark seam, Control E and then mark sharp right here. And what that's going to do is it's going to mark all of the edges on this cube as sharp. So now auto smooth basically has no control over what's happening to the shading here. Wherever these sharps are marked, they overrule the auto smooth angle. No matter where I put this now, whether it's at 0 or 180 degrees, nothing is going to change because the sharp options overrule this angle value. Now once again, for sharps to work, you have to make sure auto smooth is turned on. Otherwise, as you can see, it doesn't actually work. So sharps are nice because you can overrule the angle here. To clear sharps, you select everything, press Control E and then clear sharps. And for example, I could also just sharpen the top face, Control E and then mark sharp. So now only the top face is sharpened, but everything else has a pretty ugly shading here. So this is pretty useful because if you're working with an angle but don't want certain areas to be captured by the angle, you can simply use the mark sharp to say, hey, whatever angle you're working with, just completely ignore where I have these mark sharps applied. So I can mark this sharp. And as you're going to see, no matter what the angle is, nothing's going to affect this area here, which is super nice. But now this area, I don't have any sharps marked, so it's actually going to smooth out as I would have expected. So we can really kind of combine sharps and angles to see which areas we want to have affected by the auto smooth and which areas we don't. Here's a more practical example. Say for the bottom of this piece, I wanted it to be jagged like this, but I still wanted this bevel right here to be smoothed. So usually what I'd do is I'd adjust the angle, and you're going to see that the angle does capture this and smooths it out, but it also smooths out this bottom area, which isn't the effect I wanted. So I don't really have, a middle ground with the angle. It's either going to smooth all this out, or I'm just going to have to accept that if I want this corner smoothed out, then basically everything is going to get smoothed out. You can see how it kind of captures. So this is a practical situation in which you could use sharps, because if I want to keep this smooth but the angle simply isn't adjusting to get the bottom jagged, hopefully I'm making sense here, I can just simply ramp up this angle, capture the areas I want to have smoothed, and then just really go in here and start marking sharp, Control E and then mark sharp. So we're basically getting the exact effect we want without the angle adjusting the bottom area. Now once you start adding bevels and whatnot to really start making it look like a hard surface model, The sharps don't come in super useful. I mean, they're still kind of capturing here, as you can see, but the areas that are being beveled, such as these edges, the sharps don't really matter anymore. I could literally just remove all these sharps here, Control E, clear the sharp, and you're going to see, since we have a bevel applied now, it doesn't really make a difference. So usually this is going to work with mainly flat shaded surfaces, meaning there's no bevel there. You're not going to be using it a lot, mark sharps per se. There's going to be situations in which you'll realize, hey, I need a sharp here. But for the most part, don't spend your time questioning when you should or shouldn't use it, because as you model, you're going to figure out a situation in which it will work best for you. But most of the time, you don't need to stress too much about sharps because the bevel is going to kind of take over anyways. So here's a good example from our Sci-Fi crate design course. As you can see, the shading's pretty bad on this, so we're just going to go around to the areas where the shading's getting stretched, and we're going to mark all of those edges as sharp. So as you can see, once that sharp was applied, the shading issues basically went away, and then we can go ahead and deal with getting our bevel to work as we want it to. So in my opinion, sharps are used as a temporary shading fix up until you apply your bevel, where the sharps don't really matter anymore.
Hi guys, Ryu here, and I'm gonna talk to you about bevel weight. There are many ways of interacting with geometry when it comes to bevel, and one of them is angle, which is by default set in Hard-Ops. So when I add a bevel to geometry and go to my settings, you can see that the bevel is set to angle, and the angle's 30 degrees. So always peachy, but the problem is gonna start when the angles of geometry, so the angles between two faces, are lower than 30 degrees. So watch this. If I add a loop tool in here, go to face mode, grab this, GZ, go down. Now watch. See that this edge here was not caught by the bevel. It's just, you know, sort of bent. If I go any lower than that, it's gonna get snapped. See that? It's snapping now. And the reason for it is that this angle is simply shallower than 30 degrees. It's probably like, you know, 20-ish, right? So now the way to combat this would be either change the angle here to something smaller, which I wouldn't really recommend, because remember that this will include all the angles. If I go to bevel and press Z, you can see that all these faces here will be affected, right? So if I change the bevel angle, the angle between the faces is gonna be included as well. You can end up with like a faceted bevel. So you don't want to do that. So now the way to combat this, right, would be to add bevel weight. Now in Hard-Ops you could set which attributes you want to assign to an edge when pressing sharp. Now you could have a crease, seam, weight and sharp at the same time. I want to apply just B weight, so bevel weight, to show you how it works. Now before we do anything, let's change this bevel from angle to weight. So the limit method from angle to weight. Now you can see that we lost the bevel. And the reason for it is that none of these edges has weight assigned to them. So let me resharpen this. So I'm going to click on sharp. And now you can see that bevel weight was added to the edges. You can also see that this edge here was not caught by the bevel again, because it wasn't actually, the bevel weight wasn't added to it. To fix this, we could either change the way sharpens works. So we could change the angle of sharpness and make it a bit more shallow, which again I would not recommend messing with. The best way to go about it would be to simply grab this edge, Q, and mark as sharp, which will add bevel weight to it. And now you can see that this bevel is, this edge is properly beveled. Doesn't matter what angle you're gonna have it at, the bevel is gonna stay there. And that's how you use bevel weight in Blender. Now bevel weight can be adjusted. It goes from 0 to 1, where 0 is 0 and 1 is the maximum value, which means the maximum bevel. To change that, go to End Panel, Item, and go to Edit, select everything, so all the edges, and you can see it in here. So mean bevel weight, and you can actually slide it back and forth to adjust it to your liking. That should cover the most important things about bevel weight in Blender.
And okay, now for a quick change in the deepness of voices here, I'm going to quickly demonstrate the vanilla tools to use this, just to kind of encompass everything. So you just watch Ryu's part, and that was including Hard-Ops, and you can do the same exact types of things with vanilla Blender, obviously, so I'll just quickly discuss that for anyone interested. So here's the example he used. Obviously you can add on a bevel modifier and make whatever adjustments you'd like. You could smooth it out, set that to angle, and then harden the normals, right? Okay, so you obviously know what bevel weight is now, but if you want to add bevel weights in Vanilla Blender, you simply go to the bevel modifier, click on weight. You're going to see nothing is beveling right now because we haven't set weight anywhere. So to do that, we simply select the edges we want to have a weight on. If we press the N key and go to item, you're going to see this mean bevel weight option. So obviously, Ryu just showed you how to do it in Hard Ops. This is the way you do it in Vanilla Blender. You just drag this up, and now you're going to see it bevels those edges there that we have selected. Or I could just select the whole thing and capture all of those edges to bevel the entire cube. And it looks like his example had a little bit of a bigger bevel, and he also had an edge down the middle. So if we just kind of go back to what he was doing, obviously this angle is not going to matter because the limit method isn't set to angle. If we changed it, then the angle is going to kind of catch. You can see it's catching right there. But when it's set to weight, it's only basing it based off of the mean bevel weight settings. As you can see, the angle isn't being captured. So in Ryu's example, he basically went in here and set that mean bevel weight manually. We'll put this up to 1. And now you're going to see we have a nice bevel in there as well. Maybe a bit too big, so you could, of course, drag that down a little bit. And you can see there's kind of a harsh little area here, and you could change that with the miter type to a patch or something. Sometimes it doesn't shade very nicely though, so you could either change it to patch or arc, or you could simply just bevel this entire edge loop here. I think that's just an easier strategy. And one last thing, the offset here is uniform for every single edge that we're affecting. You can see this entire thing changes. So if I want, say, a smaller bevel on the top, then I'd have to go into these top edges here, and I'd have to adjust the mean bevel weight to change that up a little bit. You can see it gets a little bit crazy because the bevels might start pinching, so I wouldn't recommend this, but if you ever needed a slight change in bevel, this is a strategy, although not one I would employ myself. One quick thing worth mentioning if you're using Vanilla Blender, under Normals, make sure you tick on Auto Smooth so the shading gets captured nicely as well. So that's about it. Ryu discussed the Hard Ops application, and this is basically the same thing, but just how you would accomplish the same task in Vanilla Blender.
Hi guys, Ryu here, and let's talk about apply scale. Something that you're gonna be doing a lot. So better get used to it, because it's important. Let's create a cube and let me show you what I mean. If you create a cube, it's gonna be 1 by 1 by 1, okay? So this cube has simply a scale of 1 on each direction. That's a scale, right? Now watch what happens when I actually rescale this in edit mode. So I go to edit mode and I'm gonna rescale it. I'm gonna go back and the scale is the same, 1, 1, 1. However, if I do the same thing in object mode, look at these numbers now. See, that is rescaling on y-axis. So now the scale is not uniform, the scale ratio is not uniform. If I'm gonna try to bevel this edge, you see it doesn't really work very well. Now in order to make this work, we need to reset that Y scale to 1. So instead of doing it manually, which you can, you simply go to Ctrl A and apply scale. And this will reset scale of each axis. And now if you try to bevel this, everything works fine. So again, in edit mode, if you resize something, it's perfectly fine, but if you do it in object mode, you will need to apply scale. Now the cool thing about box cutter is that it will automatically rescale the object. If you try to boolean something in Blender, it will not work that well. So check this out. If I grab this cube, right, and I'm trying to, let's move this cube here and move it down. And I'll try to cut it, so Control minus, right? Now watch this, the cube is scaled properly, so the ratios are proper, right? They just equal, but this one isn't. Now watch what happens when I do the same thing with box cutter, yeah? Watch the numbers. The moment I start drawing this cutter, yeah, it applies a scale to the object automatically. So now if I shift it to live, both my cutter and my object have the same scale ratio. This scale is especially important for beveling, so you know, stuff like this, right? Or as I showed you on the corner here, when the scale is just uneven here, you're just gonna get weird results. So when you resize something, get into the habit of applying the scale. That's it for apply scale. Thanks for watching.
Okay, in this video we're going to discuss creases. Now, creases and sharps, especially among beginners, are oftentimes confused. Creases are to be used with subsurf pretty much all the time. So in hard surface, we use subsurf not too much, but if we do, it's usually at the top of the stack just to increase the mesh density from the get-go. So say for example I add in a subsurf by pressing Ctrl 3, so it gives us a subsurf with 3 viewport counts. Well, this is actually a quick way to add in subdivisions to increase the mesh density of the cube without having to, do it in here manually, which is fast enough, but sometimes subsurf is just simply easier to do. So check this out. If I took the default cube and subdivided it 3 times, take a look at the mesh density, just absorb this in, look at it, and let's say I add in a subsurf with 3 subdivisions instead, well, it gives us a sphere because it kind of averages all the edges out. What we can do is crease the entire thing with Shift E. With everything selected, Shift E, we can press 1 to give a full crease, and then watch what happens if we apply the subsurf here. Literally exactly the same mesh density. We just were able to do that with the subsurf modifier, and the creases were there to basically prevent the subsurf from making it round. And after you apply the subsurf, you're more than welcome to remove it. You can also go to the end panel here under item and turn that off. You don't really need those creases anymore. So as you can see, creases are useful to use subsurfs, but without rounding or making the edges smooth. It keeps that hard surface design. Now, creases are especially useful primarily when you're dealing with booleans and ngons. Obviously, if you add on a subdivision surface modifier with ngons, the shading and distortion goes crazy. I'll demonstrate here. What I'm going to do is just add in a simple cutout. I'll do a cut like this. Actually, this is still going to give us quads, so what I think I'll do is use an ngon cut and just put in some really basic design here. And then we'll go ahead and apply that boolean to lock in the geo. So now as you can see, we have this, we have an ngon up here, we have an ngon here, ngon here. You can see this is a face with more than 4 edges and an ngon here. Now some of these are super near miss, so let me just merge these two. Just clean that up a little bit. If they're super close, there's no reason to not just merge them like that. So that looks pretty good to me. Now if we want to increase the mesh density, it's not as easy, because if we start subdividing, kind of gets really congested and weird around here. So we can actually just use a subsurf modifier. Try it again. You're going to see it works okay, but the shading's terrible because it's trying to subdivide these ngons here. So we can simply go around to these edges. I'll just hold Alt and click. We also want to get these interior edges here, so be careful. We'll just go around and click all of these, and you can turn the subsurf off to make sure you got everything. Looks like we did. We'll turn that back on. Increase the mean crease to a value of 1. Check this out. Already looks way better. Now sometimes you have to really get in here and clean up some of these other areas because it gets rounded strangely, so maybe I'll go in here and join that up. Go to the other side, do the same thing, join this up, and perhaps what we could do is just simply use the auto merge and slide these down. So double tap G and get these merged together, and we're going to have to re-add the crease here. Look at that. So now we have completely clean shading here, and if you still didn't want this area to be rounded, simply go in, boom, drop a crease. There you go, it's not rounded anymore. So any areas you don't want to have rounded, you can use a crease for. As a matter of fact, I'll just do that to the entire mesh. All these corners are rounded because of the subsurf, so I'm just going to go in here, get all these guys tightened up with a crease. Almost done. Just got to grab these here. Increase that to 1. Check this out. No more weird roundedness or anything. We can go ahead and apply the subsurf and take a look. We've increased the mesh density a lot without having any weird distortions because of the ngons. Now the planar surfaces look really weird. Usually what I like to do on the planar surfaces where the ngons were is I like to simply select a face, Shift G, and then coplanar. Same thing for these. We'll just go around and coplanar. It looks like this one's a little bit angled, so maybe we'll just really get in here and just start painting with the circle select tool. Like this. And then same for this guy, coplanar. And then you can simply press Control X to dissolve those areas out. And if it dissolves the whole thing, sometimes, unfortunately, you have to do all these manually. So we'll just go in here and do all of it manually. Just get in here. I'll show you a quicker way after this. I just want to show you one way you could clean this up. Control X, and then Control X. So now, as you can see, the geo looks a lot cleaner, and we're not going to really have any issues with these crazy ngons because we're working with hard surface and bevels. Now, I probably put the subsurf way higher than I needed. A count of 1 or 2 would have probably been fine, because now if we try to apply a bevel, it's going to overlap basically immediately because of how close these edges are. So you might have to go around and dissolve some of them out to capture that easier, but yeah, you should get the point by now. So yeah, this is a quick and easy way to increase mesh density without getting any sort of distortions with the subsurf modifier. Like I said, sometimes you'll have to go in and dissolve out edges so the bevels don't overlap. Prime example, if I undo this here, I was just cleaning it up off camera. As you can see, these bevels overlap so soon. So you either need a really tiny bevel, which is not really optimal, or you just go in here and turn off the bevel so you can see it, and just dissolve out some of these edges that are closer to the edge. Control X, and yep, there you go. Just a quick and easy way to increase mesh density and get yourself some more geo to work with.
Hi guys, Ryu here, and let's talk about subdivision modifier. Subdivision modifier, basically what it does, simply subdivide your mesh into smaller bits. So if I have this plane and I subdivide it and press Shift R, it will keep subdividing this plane. So that's literally what subdivision modifier does, that's all. So let's create a pipe really quickly, right? So let's grab a plane and let's remove this vert, and let's curve this one and create a pipe really quickly with hard ops. Let's maybe smooth it a little bit. So apply visual geometry to mesh, and now we have this mesh, right? And we want to have a bit more dense mesh to make this curve a bit smoother. Now for subdivision, what you need is quad geo. That's just the best way it works because it subdivides nicely. You can run loops through quads. If you have ngons, like for example this one, right? That's an ngon because it's more than 4 verts. The loop will not work. You see, it will stop, okay? Because Blender doesn't know which way to go. So if I remove this, right, really quickly, now I'll show you how subdivision works. So let's add one level of subdivision by simply pressing Ctrl 1, which will add subdivision modifier to the mesh. And how it works is simply when you apply it, you will see it simply makes this mesh more dense. Don't worry about it, it's just messed up because I subdivided it manually. You know what, let's just go back in time and fix it. There we go. So let's do it again. Ctrl 1 and apply it. Now everything is peachy. So you see that it simply added more mesh onto it. And you can keep going. Let's say Ctrl 3, and if you apply this one, it's going to be really dense, yeah? See what I mean? That's crazy dense. So that's how you create subdivision on meshes. It's useful when you want to bend an object, okay? Or create more supporting geometry, for example, for booleans. Or you just simply trying to make something look smoother, right? So let's grab this plane and rotate it. You know what, let's rotate it properly. So RX90, and let's try to bend it. And I'm going to actually just introduce 2 loop cuts in here, okay? And now what I'm going to do is simply use hard ops because it's easier, and I will apply rotation to this object. So apply rotation, there we go, and now we can actually bend it on the z-axis. So let's actually adjust the angle to a -1, right? Now you see what's happening is that this item doesn't have enough geo to support this bend, but if I add Ctrl 3, now you see it's just smoothly bending across. Of course I have to shade it smooth, right? See what I mean? So this subdivision actually is allowing this object to be bent smoothly, and the reason why it's actually curving on the corners is because we don't have any creases on it. So if I'm going to select all these edges and simply go to my hard up settings and add crease to my sharpen and I mark these edges as sharp, you see everything is fixed now because these edges have been creased, okay? So that's how subdivision modifier works. Basically what you want to support the subdivision modifier is either add creases like I did here. Alternately, you could actually add a bevel. So if I press Z here and go to 3, so you will see what's happening. This is a sort of like a supporting bevel. So let's press Z again. See, like a really tiny supportive bevel. And if I now subdivide it, so press Control 3, you can see that the edges are holding. If I turn off the bevel now, okay, you'll see what's gonna happen. So it turns into a sphere because literally edges are collapsing into a sphere. So these bevels actually holding the whole structure. So if I apply this, you'll understand. You see these edges here that I created, these ones, they're actually holding the structure firmly together. So either you do this, or you simply add creases. It's, you know, it's up to you how you control this mesh, but these are the two ways of controlling a subdivision mesh. And again, if you want to have your subdivision to work properly, you do need quads for it, because it will work on ngons, but the results are usually unpredictable. It's just I wouldn't recommend it. So if you have a lot of ngons, probably would be doing it manually, or try to at least get into quad mode before I start booleaning something. So if I was working with subdivision and I knew I want to boolean this, right, I would never bool it first and then add subdivision. I would just do it the other way around. So first I would subdivide it and make it smooth, and then I would start boolean the shape. So first you need to form it and then you slice it. That would cover the most basic information on subdivision in Blender. Thanks for watching. Hi guys, Ryu here, and let's talk about flipped normals. Geometry has two sides, inside and outside. Every face has two sides, okay? If I'm gonna go to this option here, face orientation, you'll see that everything is blue. Blue is good, red is bad. Now if I flip this face, so change it orientation, so the inside, the inner part's gonna be actually the correct side, and this one is the inner part being flipped inside out. And I'm, for example, gonna go to bevel. You see that it doesn't bevel very well. So let me turn it off for a second. See what I mean? So when you have shading issues or any type of issues, you might want to check your normals first. And I can flip it back to either by choosing flip or recalculate outside. It will simply flip the mesh, all the selected mesh, because you can select all the faces, right? And it will flip them to the outside. So the options here are flip to the outside, and recalculate inside, okay? So the way you flip will depend on which side you need the faces to face towards, you know? If you want them to face inside of the mesh, then you need to flip them inside. If you want them to face outside, you need to flip them outside. And that should cover the basics of flipped normals in Blender. Hi guys, Ryu here, and let's talk about ngons. What is an ngon? It's very simple. Ngon is any type of face that has more than 4 vertices. Because 3 is a triangle, 4 is a quad, and more than 4, so 5 plus, is an ngon. So for example, even though you see a quad in here, this is already an ngon because I just added one more vert. Now, why ngons have such a bad reputation? And is it actually really deserved? Well, there are myths and truth about ngons. The myth is that ngons are always bad, and the truth is that ngons are sometimes bad. But the same thing goes to quads. Quads are sometimes good, and quads also are sometimes unnecessary. Now let me show you what I mean. See, if I try to subdivide this mesh by using a loop tool, right? So just inserting a loop, I cannot do it because Blender sees that this is an ngon and here is an ngon on top as well, and doesn't really know which way this edge should flow. But if I remove this and try to insert a loop, everything is fine. So quads can be very easily subdivided. So if you wanted to subdivide the mesh, you're probably gonna go ahead with a subdivision modifier, which is here, which will simply subdivide this mesh. So let me show you this on an example of a plane, okay? So if I went to grab a plane, put it in here and go to a top view, and then I'm going to right click and subdivide it and press Shift R to repeat that operation, okay? That's what subdivision is, okay? Just simply subdivides this quad into many more quads. If that was an ngon, a subdivision wouldn't work that well. And you see these areas, right? They were subdivided really densely. Let me switch off the X-ray effect. You see these subdivisions here? That was a mesh which was simply subdivided into smaller quads to support this this curvature. And when this mesh is gonna get, you know, triangulated and exported to a game engine, shading is gonna be perfectly fine. These ngons, the small ones here, right? These are ngons. You see 1, 2, 3, 4, 5, etc. They do not matter because it's so tiny, and the curvature they lay on is so minuscule that it literally will have no effect on shading. So now when you create ngons, right, when you use ngons, you need to know how to use them. For example, here is a very good example, right? If I go to edit mode, you see, this is an ngon, right? 1, 2, 3, 4, 5, 6, 7, 8 vertices. Now this would be tricky if you bring it to a game engine because it actually lays on a curve. So I would need to probably, if I wanted to bring it to a game engine, would need to make sure that game engine properly triangulates this mesh, or I would need to actually run some supporting loops here and cut this ngon to something smaller and more digestible. Okay. However, in this case, if you were, for example, working on a, you know, on like a concept project, right? It doesn't matter because, you know, shading is perfectly fine. You see, there's no problem with shading in here, and it's an ngon. And there are plenty of examples like this on this flat surface here, right? And this one. This ngon doesn't matter because it's a flat surface. There will be no point of creating additional loops and edges because it would add unnecessary geometry that literally this mesh doesn't need. So again, you need to understand that ngons are perfectly fine on flat surfaces that will not deform, or curved surfaces when you know that you can control the shading when you're using them. Quads are usually great anywhere. However, if you use two big quads on very, you know, aggressive curves, you're gonna have the same problem and the same shading breaking. In addition, trying to make geometry all quads is unnecessary in a lot of cases in hard surface modeling, especially if you're not going to subdivide the mesh. So if you know, you need to know what this mesh is gonna, what kind of purpose the mesh is gonna serve. If you know you're gonna subdivide it, you might have a problem with ngons. If you know that you do not need to subdivide it, you're perfectly fine. And again, flat surfaces, you're fine. Curved surfaces, you got to be careful. Surfaces that deform, I would probably avoid ngons, or make sure that the shading looks fine after bringing it to the game engine. So you need to actually test it yourself. The trick is to learn how to control the shading, know what, you know, how the geometry behaves. If you look at this mesh, I mean, these are all slices. This is, you know, these are not decals. These are literally sliced meshes, okay? This is all sliced, all of it, okay? These are all separate pieces. So they're all booleans. And booleans create a lot of ngons. This is a boolean too, right? This is a real geo. This is a real geo, you know? These are real geos, right? It's all is sliced, okay? So it's really not a problem if you use ngon, if you really know how to use them. Look, the shading is really nice here. It's perfect. It's, you know, it's flawless. But I guarantee you there are ngons on this bit because, you know, it's unavoidable. It's a boolean, so you will have ngons, but they're perfectly fine because again, mesh is dense enough to support it. So when you create something and you want to use ngons, always make sure that you know what purpose these ngons gonna serve. And that's all about ngons from me. Thanks for watching. Hi guys, Ryu here, and let's talk about non-manifold geometry. To understand what non-manifold means, let's talk about manifold first. A manifold in mathematics, in 3D in this case, means an unclosed object where all the edges, points, dots, faces are connected and they form a watertight object, which means if you pour water into it, no matter what you do with the object, you stay in it. It's hermetically closed, okay? The opposite of it will be non-manifold object, which means with edges or faces being split. So if I move a vert, you can see that everything moves with it, all the edges. However, if I go to edge mode and press V to rip it off, now if I move this, you can see we have two verts, because one is for these edges and one is for these edges. And this is a non-manifold geometry because you can see there is a hole in it, and if we pour water in it, it's just gonna spill out. So non-manifold geometry is bad for many situations. For example, if you want to run a bevel through it, you're not going to be successful because you're going to have a lot of shading issues, right? The bevel just will not run through because the geo is not closed. So you want to close it, which means I would usually use something like machine tools. Just press one and, close it and you're fine. And you need to do the same thing on the other side. So press A to select all, 3 to clean it, and I'm done. Now another tool that comes with Blend, Machine Tools by the way is a free add-on, so you don't have to pay for it, but you can also use the add-on that comes with Blender, and it's called 3D Print Toolbox, and that add-on can be installed directly from Blender, and it's this one, 3D Print Toolbox, okay? And you can go to the end panel, open it up, and under Make Manifolds, on the cleanup, you'll find this Make Manifold Geo option. Sometimes it works, sometimes it doesn't. But non-manifold geo is always something like this, so just edges or verts floating in the air. And this can happen when you, for example, slice, mesh, boolean it, merge together, etc. You have a lot of non-manifold geo that simply is unnecessary. You need to clean it. So again, if I was working on my model, I'll simply go with machine tools, so select all three and I'm done. But it again depends on what type of geometry you're working with, what kind of non-manifold geo we're talking about, what's the damage, etc. But that's in essence what non-manifold geometry means, and why sometimes it can cause you problems with shading, bevels, booleans, etc. Well, that's all you need to know about non-manifold geometry. Thanks for watching. Hi guys, Ryu here, and let's talk about weighted normals and hardened normals in Blender. Now for hard surface modeling, it's really important to have really good shading. And by good shading, I mean flat faces flat and nice curvatures curved. So when I create a cube and I'm gonna add bevel to it, and then I'm gonna slice it, you can see that the shading breaks, right? On this face here and here as well. Now when I add weighted normal modifier, it gets fixed. Now why is it so? Well, Blender takes into consideration to compute all these curvatures on the bevel, right? All the faces of the cube, the big ones, the small ones, everything. Weighted normal modifier and hardened normals, what they do is they simply tell Blender to exclude all the big faces that should remain flat, and takes only into consideration faces that are actually small, so these ones that actually curve. And that's what's happening in a nutshell. But how does it work and why? Well, if I go to my vert mode, you can see that I have these blue lines coming out of the verts. These are called normals, and you can enable them in here, okay? Now, if I'm going to apply the boolean and the bevel, right, you'll see more of these. Now check this out. You see these normals here? They actually point in the direction of the face orientation, because face, every single geo, but let's just take a plane, right, has an orientation. Okay, there's a top side towards which the normals point and a flip side. An easy way to check it is to go to face orientation, and the red one is bad, the blue one is good. Okay, So this is an inner face, inner geo. Geo has two sides, and that's important to know. Now, let's go back to our example here. We do have a weighted normal modifier running on this mesh, but it's not being applied. So let's copy this here and actually apply it. And I'm going to grab these two cubes and compare the normals. Now look at these ones. These two. They're different, aren't they? See, now this one is perpendicular to this face, so the big face on the top, and this one isn't. Because in this case, when weighted normal modifier wasn't applied, it's non-existent, Blender is taking this top face into consideration to compute all these curvatures around it. That's why the face bends, because it bends, tries to sort of accommodate all these, shading breaks on the bevels. Well, this one stays unaffected because it's flat, and only small faces are taken into consideration. And that's what weighted normals and hardened normals do. Now, there are two ways of applying both, okay? With hard-ups, of course. Now, I showed you how to use weighted normals, but let's talk about hardened normals for a second. If I'm going to create a bevel on this cube and go to bevel modifier stack, I can go to shading and check hardened normals on or off, and it's exactly the same effect as if I was adding weighted normals to this cube. So now what hardened normals does is tells Blender to treat all the new faces the same as it treats the faces on this mother cube. So the big faces here, right, they're gonna stay flat and the small one's gonna get curved. That's why the shading is perfect. Now let's talk about the other ways of adding these attributes to your mesh. You see these in Control tilde menu, you have these two options here, right? So weighted normals, if I check this on, go to my mesh, add bevel, then I go to sharpen and Control click on it, it will automatically add sharpen to all edges and also weighted normal modifier, right? So you see edges were sharpened and modifier was added. If I, on the other hand, going to uncheck this and check this one, whenever I add bevel, the bevel is gonna come with hardened normals ticked on. It works in the same way, just different approach. Now the difference between both is that actually weighted normal modifier, right? So if I'm going to add a weighted normal here, so let's add a weighted normal. You have more options with it. You can simply, play with the options, play with the weight. So if I'm going to actually make some cut in here so you can see it, I can actually, adjust the weight of this modifier, you see? So I can affect how it shades. So you can play with it. But to be honest, I never do. What I do in my workflow, personally, right? I go to, bevel, whatever, do my cutting, and I simply alt-click on sharpen, and I'm done. And I know that my weighted normal modifier is going to be always added by hard-ups to the end of the stack, because that's how hard-ups is actually managing modifiers, and weighted normal should always be at the end of the stack. That's all from me on weighted normals and hardened normals. Thanks for watching. Hi guys, Ryu here, and let's talk about default add-ons in Blender and which ones are useful for hard surface modeling. So when you go to Edit and Preferences right here, you can open this window, and under add-ons you can add or remove Blender native add-ons. First of all would be a bool tool. And bool tool add-on is used for boolean operations. I don't really use it, to be honest, because I'm using hard-ups and box cutter. However, it's quite useful. So for example, if you have a cube and you duplicate that cube and you select both and press Ctrl-, you're gonna act as a difference boolean, and Ctrl// it's gonna be a slash, and plus it will be a join, a union boolean. So it's simply adding a shortcuts to your boolean operations, make it much more easy to perform. Another add-on will be loop tools. This one is really useful, okay, loop tools. Let's grab a plane and let's duplicate it, okay, somewhere here. And let's merge them together to one object. So Control J, and let's grab an edge, and this edge, right click, and you can access loop tools here. And you have a lot of options, okay? Bridge is one of them. It will simply fill the face or faces between the gaps in geometry. It has to be one object though, yeah? Another way of using this add-on will be to create a circle. So if I subdivide it, let's say once, well, let's subdivide it a few times, okay? And let's grab these four in the middle and loop tools and circle. See, it's gonna create a circle. So then you can extrude it, and you can subdivide this mesh because it's, you know, perfect quads, which means let me show you. So if I select all these edges and extrude them down and create a face, so now I would need to secure these edges with bevels or loops. So I'll do it manually. So let's grab these and the corner ones as well. And we could either do it with a bevel, or we could actually add crease. So let's add crease and crease it to the maximum. And then when I add subdivisions, so Control 1 or Control 2, you see that it will get really nicely subdivided. So if I smooth it, right, you're gonna have a nice cut inside, and it's all quads. So anyway, that's a few tips on how to use loop tools. Another tool that you might be interested in is mesh tools. So edit mesh tools, this one, yeah. So mesh tools are here. Just right click in edit mode, and there you go. And you have all kinds of interesting options. For example, flip normals or triangulate faces, right? Or you can merge vertices by distance. So when you have two vertices really close to one another, you can merge them. Another very useful add-on, and in my opinion essential one for your workflow, would be Node Wrangler. So Node Wrangler is going to add a lot of shortcuts to your node work. So when you in shader editor and you work on nodes, whether it be materials in object mode or in world mode, for example, I'll show you in a HDRI file example. So if I delete these nodes, right, if I want to add these nodes back, and you know, let's say I'm in a new Blender and I want to work with nodes, all I need to do is click select this background node and click Ctrl T, and this will add and connect all these three nodes that are essential for working with HDRI background for my rendering scene. And if I go to cycles and add some cube and add some material with hard ops and turn off the transparency, you can see that HDRI has been added to my scene. That's how easy that is. So Node Wrangler is a must-have in my opinion, and you should definitely have it enabled. Another add-on that I want to mention is F2. I do not really use it because I use machine tools for this one, but this allows you to add faces to an object quite easily. So for example, if I had a cube and this face was missing, right, and I wanted to add it, all I have to do is select this edge and press F, and it's going to add it. However, if this cube was subdivided, right, so let me subdivide it. Now let me select everything first, subdivide it and press Shift R a few times. And now let's say I'm going to just, you know, select these faces and delete them, right? So now if I went with our F2 method, it's not going to really work that well, because you see the Blender gets confused and doesn't really know how to fill this face in which direction. So it's not that straightforward. However, the reason why I use machine tools is this. All I have to do is press 1, vert, press and hold 4, and the magic just happens. And machine tools add-on is free as well, so there is nothing stopping you from downloading it, and I think it's much more powerful than F2 add-on. Another very useful add-on would be copy attributes. This one, copy attributes menu. This one is really important. So let's say you have a cube which is rotated and has a bevel on it and weighted normal modifiers, okay? So we have two modifiers running on that cube, right? And I want to copy these attributes to a new cube, which is this one, right? So I want to copy the rotation and the modifiers. So instead of duplicating this cube and placing this cube exactly in the position where I want it to be, I can simply copy the attribute. So I select this cube, and then Control C and I copy rotation, Control C and I copy modifiers. And then all I have to do is change the bevel profile to the same one as on this cube, and I'm done. And this one has also weighted normals and bevel modifier just like this one. Now I want to mention 3 more add-ons very quickly. So one of them would be 3D box tools and solid type tools, and it's this one, 3D print toolbox. Sorry, I never remember the name. I don't really use it often, and this add-on, by the way, appears only when you actually have some mesh in the scene, right? And it's here. And the only function I'll be using is make manifold under cleanup. So what it does, it simply cleans up non-manifold mesh. But to be honest, I'm using machine tools for this as well, because it's just so much easier. If I have some junk flying around, all I need to do is go to edit mode, press 3, and I'm done. Now 2 more add-ons that actually are worth mentioning, and I don't really use them that often, but they're useful. So if you type extra, you can see there are 2 of them, for curves and for mesh, simply more objects for each. So if you go to Shift A and you go to your mesh menu, you can see that you have a lot more objects than in a default menu. And the same goes for curves, there's just plenty of them. So if you need some specific curves or specific mesh of very weird shapes, these add-ons are for you. And that would cover, I think, the most important add-ons for hard surface workflow in Blender, add-ons that actually come with Blender as a program. Thanks for watching. Hi guys, Ryu here, and let's talk about merging verts. It's a very useful thing to know how to merge verts, especially when you work in hard surface. You're going to be doing it a lot. The way I do it, I use machine tools, which is a free add-on. I simply select 2 verts, press 1 if I want to merge at last, or shift 1 if I want to merge in the middle, and that literally does me. But you can also turn the auto merge function, so when I, for example, slide one vert to another, they get automatically merged into one. Now in Blender, what you want to do is select both, press M and select your option. You can also select to merge them by distance, which means that if I have 2 verts on top of one another, there's still 2 separate verts, and I'm going to select them both or everything. Go to M and select merge by distance. They will get merged depending on the distance, and the distance can be adjusted in here under this F9 menu. Way in Blender to actually turn auto merge is here. So if you go to this panel, so it's above rendering, this one, and go to options and turn auto merge, anytime you slide a vert, they're gonna get merged together. And that's all you need to know about merging verts in Blender. Thanks for watching.
What's up guys, Josh on this video, and I want to discuss reverse bevels. This is something that is super useful, especially if you're making designs with handles. So I'm actually just going to use the basic cube as we always do. And I'm going to demonstrate the quickest way to do this first of all, which is with hard ops, and then I'll show you how to do it in vanilla, just so everyone has a good understanding. So if I press the D key to get into box cutter and use a circle here, I'll enable snapping and pull out a circle from here, maybe drag it in. Now you can see these edges aren't beveled or anything. I mean, I could bevel them and get something like this, right? But what if I want the bevel to kind of go at more of a chamfer inwards? So here's a pretty good example. This is what I meant by handles. You can kind of finesse the design a little bit. If we zoom in here, you're going to see that there's kind of this inward chamfer going on, or not technically a chamfer, but just a one segment bevel going on. Now doing this is super easy. All we need to do is recall the cutter with mod scroll. We'll bring that back. And then if we tab into edit mode and select this front face, and in hard ops we press Q and then control click mark, check this out. It does a reverse bevel for us. And then you can of course just hide the cutter, and there you go. This is a design I use personally all the time, especially if I'm trying to get some sort of handle going into the mesh, but I don't want to have to deal with unioning it to the mesh to get it looking nice. And like I said, I like to use this design to kind of make my designs a little bit easier to work with, and I don't have to deal with using a ton of crazy union booleans, so you can get something looking like this pretty quickly. Anyways, that's how you do it in HardOps. Let's discuss what's actually happening behind the scenes in vanilla. So to do this in vanilla, it's the same idea. We would simply use a cylinder as a cutout, maybe 64 vertices to make it more detailed, rotate it 90 degrees, scale it, pull it in. You know the drill at this point. So I'm just going to use the HardOps or Bool Tool add-ons. I've already showcased how to use this, so we don't have to go through the whole Boolean process. I'll just shift select the cube here and press Control minus. And now we have a cut. Looks really nice. And what you're going to see is that if we, for example, if we pull this guy in, maybe scale it, put it right at the front, you'd think that we would just go to the front face and press Control B to bevel, but it's beveling the wrong way. We want to reverse this bevel. So to reverse the bevel, you simply just flip the normals on this front face. So we're just going to go to Mesh, Normals, and then flip the normals right here. And now if we press Control B, it's going to bevel in the opposite direction basically. Maybe we'll just pull this out so it's a little bit more outwards, and then we can of course hide the cutter. And you're going to see there's a lot of jaggedness here, so let's go ahead and shade smooth, auto smooth, and then we'll make sure we shade smooth the cutter as well. Now sometimes the shading won't look good even after doing that, and that is probably because the auto smooth angle isn't catching it. So you can either adjust the angle on the cutter, or you can simply adjust the angle here, and then it should catch it. Okay, now some people like myself would prefer to keep everything non-destructive, meaning we're not actually affecting the cylinder at all. We can just go back in here and change the bevel whenever we want. So if you wanted to make this more non-destructive with the cutter, you could do that simply with a bevel modifier instead. So what I'm actually going to do is undo this right before I even did the bevel. So right here should be fine. And then I'm going to go to Add Modifier, Bevel, and we need to make sure we choose the front face only as where we're going to bevel. So we could either use weight or we could use a vertex group. I'll simply use a vertex group. You're going to see that's going to be how it's affecting it, is through that vertex group. Then we're going to go in here, plus, and then assign a new vertex group here. And then all we have to do is actually select that vertex group so we know what we're affecting. And now we have full control over this cutter, and it's completely non-destructive. So we can kind of change this bevel whenever we want really. And there you go. And then same idea, we of course need to smooth the cutter and then smooth the cube, auto smooth the cube, and then we might have to just adjust the angle a little bit. And that's how you can do it non-destructively. So this is a design I make all the time. It's something you'll use a lot in Hard-Surface, so hopefully this video helped you understand it better. Okay, this is going to be a super short video on the usage of seams. Now, usually you use seams in UV unwrapping, and that's all completely fine. Keep doing that. But there is one other usage that we use a lot in Hard-Surface. Okay, so I'm not going to get into how unwrapping works. That's obviously a completely different topic. But adding seams is probably the easiest thing to do in Blender. You just select the edges you want to add seams on. You press Control E, and then you can mark the seam. You can also do this with HardOps. If you press Control tilde and tick on the Apply Seam option, you can simply go to the Cube menu and mark your edges that way. But yeah, you can just press Control E in Vanilla Blender. Now what we have here is the seam on the top. And if I were to select Linked Geometry, maybe Linked Faces, if I press L, you're going to see we can select within those seams, and these two areas are separate while still being the same mesh. And if I were to select everything and clear the seam and select any linked geo, it's going to select the whole thing. So you can basically use seams to separate areas of the underlying geometry and have easy selection points. That is quite literally all I'm going to showcase here. I thought it would be a quick tip people could use, so that's about it for this video. Okay everyone, in this video we're going to quickly discuss vertex groups. A lot of you probably know what this is. If you are familiar with Hard-Surface, they're pretty useful. So vertex groups allow us to assign a set of vertices to a single group, so that way we can work with that specific set of vertices only. So I'm going to go in here and demonstrate. I'm going to tab into edit mode, and a vertex group is very simple. You select whatever vertices you want to group together. You go to this green triangle panel. You go to vertex groups, click on the plus icon, and then you'll have this assign option here. If we click on assign, you're going to see now if we select and deselect, we have our own vertex group. We could also do the same thing with these two. Maybe assign a new one. We'll click on assign, check this out. Select and deselect, it's just those two. And then down here, maybe we could just assign a single vertex. We'll do another group, assign. And I always like to double check to make sure it actually went through. Just select and deselect, make sure everything is good to go, which it looks like it is. Now, I most commonly use vertex groups on bevel modifiers, but you can also use them on things like shrink wrap, data transfer, all sorts of different modifiers. Nearly everyone will have some sort of option for vertex group as long as it supports that. I'm going to go ahead and demonstrate it with a bevel modifier because that's when you'll probably use it the most. And we're going to go here, add a bevel modifier. You're going to see by default we have our limit methods. We have none, we have angle, we of course have our weight, and we also have vertex group. So if I click on vertex group, I can choose the group that I want to use. So if you remember, these top four were our first group. You can see that in here. So if I were to select the first group, which is just called group, and put that in here, you're going to see the only area affected is this top area, and I can simply go in here and adjust the offset, do whatever I want, rank up the segment count, all sorts of cool things. Now I could also do the same thing by adding another bevel modifier here. We'll go to vertex group and choose the second one there. And now you're going to see it's going to bevel this vertex group, and it's not going to affect anything else. So you can kind of do this to adjust different levels of bevels and things like that. And then perhaps for this single vertex, if I add in a bevel modifier and choose that single vertex we added, you're going to see nothing happens, but that's because it's a single vertex, so we'd have to tick on only vertices here for it to do anything. Now there's no right or wrong answer as to when you should use vertex groups and bevels or really anything. It simply depends if you need them for what you're working on. So there's no right or wrong, so don't expect to get a set answer of when to use this. It really doesn't matter. Use it if it's going to help your workflow. I probably use this about 10% of the time, so not a ton, but it is very useful to have. Okay, at this point you should have an idea of how vertex groups work. I'll give you just one other example of when you could use them, but you can use them in really any situation in which they come in handy. So perhaps I'll just use Suzanne as the example. What I'll do is add in, I don't know, a cylinder, scale this guy down, scale it up, and maybe I'll extrude this bottom face. Press E to extrude. And then what I'll do is assign a new vertex group to this bottom set of vertices. Even if it's in face mode, it'll still assign it properly, so don't worry about going into vertex mode. You'll see it still captures it nicely. So another cool thing you could do is perhaps add on a shrink wrap modifier. You could go in here to the target, and you're going to see whenever you shrink wrap something, it basically flattens on top of it, and sometimes you don't want the entire mesh to collapse, so you just want to use it based off of only a certain set of vertices on the mesh. So we could choose the vertex group here, and now you're going to see it's only affecting this vertex group on the bottom here, all these vertices. If I can actually select it, just those. You know, you can move it down, you can move it up, you can do really whatever you want, and it's only affecting those sets of vertices. So this is another pretty simple example of when you could use it. But yeah, as for vertex groups, that's really about it. I don't really need to go into every single situation you can use them. It just simply depends what you're trying to do. As long as you know what vertex groups are and how to assign them, you can use them in pretty much any situation you might want them.
Hi guys, Ryu here, and let's talk about materials in Blender. So the very basics of materials is simply to, when you're in a object mode, right, you click on this tab here, and you simply click new, which will add a new principal BSDF mod to this cube, and you can change color of this mod and attribute. Now you can't see anything in here because we are in object view, but if you're gonna go to look dev, you'll see the changes immediately. And now we can play with the settings. So for instance, we could make it into metallic, reduce the roughness to make it more reflective. Then we could, for example, change add the clear coat to it, which is gonna add another layer on top of it, like on cars, you have this kind of like a metal, you know, sheet of the body of the car, and then it's a paint over it. Then you have IR values, so refractivity, and you get transmission, emissions, etc. So all kinds of settings in here. But then you could also change it to different nodes. So for instance, you could change from a principal shader to emission, and you're gonna have a glow, right? So now let me show you how it works. Blender operates on nodes. So when I open this window, if it allows me, there we go. and go to shader editor, right, you will see nodes. And we have emission node in here. That's why this object glows. And you can change strength and color of the emission and so on, right? Now, if I switch it in here to something else, I could do it from here or simply from here. So I could delete that and Shift A and go to shader and go to principled BSDF and connect this one to the surface. And I can just, start playing again with my values, right? The same way as we just did before. So you can access these values in here or in here. It's literally the same thing. However, the shader editor is much more complex and you can start stacking nodes in here, which would be difficult to access from this panel. So for example, if I go to my hard-ups and I will add some materials from kit-ups. So I'm using add-ons at the moment. This is not vanilla Blender. And let's go to metal, right? And I'm going to add this one by holding control and clicking. You can see that the entire node is going to get added. It's like a whole tree of nodes, right? So I have all different kinds of things in this setup. Let me make it bigger for you. So we have texture coordinates, we have color, we have roughness and bump. And this whole setup is being added with one click. Okay, so this node tree determines how these values here are being affected. Okay, now if I zoom into this cube, you can see we actually have texture on it, right? Metal texture. It's been added to this scene by simply loading images to Blender. Okay. Now I could do the same thing through hard-ups. If I click on a cube and go Alt-M and add blank material, I'm going to add a blank material to this cube. Now this is an emission, but I can switch it to something else. And this is emission actually that pulsates, which is why it's black, because in this keyframe it's actually turned off. But if I go to timeline and let it play, it will start working. So you could adjust all these values you see in here. These nodes actually decide how this emission behaves, and this determines the pulse rate. So you could add another material, for example Alt-M and shift click on it, and it's going to be glass. And you'll see that nodes will get updated with something new. So again, using add-ons for texturing like kit-ups or hard-ups is just making it so easy and so fun to work. You don't have to, mess about with trees and nodes. It's just, it's there for you to use. It's ready, and you can always adjust it here or through the shader editor. Now, if you want to copy material to another object, all you need to do is select this object, the one you want to copy from, and go here and copy materials, right? So that's that. When you have more than one material, right? So you add another material, you can see all the materials in here. There's a material list in here. Okay, so if you click on this, it will expand. And if you want to switch materials of some object, you simply click on it and choose a different material. Now let's say that you have an object where let's insert this face. So I and E to insert and extrude, and you want this face to have a different material than the whole cube. All you need to do is click on this plus here while you have this face selected, so you need to be in edit mode. Open the plus here and add the material and then assign it to this face, and then you will have different material on just a part of an object. And this should cover the basics of materials in Blender. Thanks for watching. Hi guys, Ryu here, and let's talk about render engines in Blender. Two main engines, Eevee and Cycles. What's the difference? Eevee is like cleaning your place by shoving everything under the bed. Cycles would be closer to calling a professional team to steam your place up and make it really clean. That's the difference, okay? Cycles is a real deal. Realistic lighting and shadows. So in short, if you want to have a good portfolio and you care about the quality of your work, you go Cycles. It takes a bit longer, but with proper settings and a half decent hardware, you're gonna stay within a range of minutes for renders. Yes, it's not that bad. Eevee is good for stuff like animations or short previews or short clips. Like for instance, the video for this tutorial that you're watching, the intro was actually baked in Eevee. So you need to make a decision which engine you want to choose. But again, if you're serious about your work and you want to create a portfolio, or you want your work to look as good as possible, then Cycles is the way to go. It's not a no-brainer. Now, how do you access render engine in Blender? This is your solid mode view, right? And you can see a weird color here because I simply have a textured mode turned on, and I have a texture running on this cube which assigns a random color in a view display, which is this one. That's why you're seeing this weird color, but you can turn it off here. Okay, so this one is a solid look. Right now, render engines are here, and this is these two tabs here. On the top you can switch between Cycles and Eevee, and you have different settings for both. So for Cycles, you can change number of samples, you can change a light path, which means how many times light bounces. You can, turn on or off transparency of your HDRI image, so if your background, all kinds of stuff here, right? Then you have size of the image and output. For Eevee, settings are a bit different. You got ambient occlusion, bloom, screen space reflections, refraction, so stuff like glass, for example. That's where you're gonna go and set it up, and quality of shadows, etc. Right? So it's a little bit different. And then you have something called look depth, which is somewhere in between, but it's more closely related to Eevee, I would say, because it kind of also emulates light, and it's really fast. You can actually work in it, so it's it's pretty cool to work in it, because you can visualize your work with materials and lighting and shadows. It's kind of cool. So you can also change lightings here, so you can switch it to the same light as you have in your main scene, because you can download and install custom HDRI files, which means those background files with light information in them. Now, once you set everything up and you want to render an image, you go here and click on render image or animation. You could also render a viewport image, which means it's exactly what you're looking at right now. So go to view and then render viewport image, and you're gonna get exactly what you're looking at. So that would cover the basics of rendering engines. Now, Eevee takes much less time to render images, but it's way less accurate as well. So you save time, but you lose some quality, a lot of it, in fact. However, Eevee is fantastic for dark images with a lot of lights, rainy, like rainy scenes with water reflections. It's kind of cool. But when you start rendering stuff like, environments, rooms, something that actually touches reality, Cycles simply can't be beaten in this competition. It just wins every time, all the time. So if you want to go realistic, go Cycles. If you want to go funky and gamey, go Eevee. But again, Cycles is the way to go, in my opinion. Now, Cycles has a bad reputation by being an engine that takes hours to render, but if you know how to set properly everything up and you use Compositor, renders that are 1440p with a lot of stuff in them, light and all that, could take not more than 2-3 minutes to render at high quality. So it's simply about knowing how to set things up. That should cover all the basics of rendering that I think you should know of. Thanks for watching. Hi guys, Ryu here, and let's talk about pivot point. Now, pivot point in Blender is a quite important thing to know, and I'm gonna demonstrate it by using two cubes. So pivot point is found here, and you have a few different types of pivot points. Now let's try the most common one, which is individual origins. If I select both cubes, right, the origin of the object is in the middle of each of those cubes. So if I start rotating them, each of them rotate around its origin point, right, the white dot in the middle of the box. If I switch it to cursor, both cubes will rotate around the cursor, right? So depending where you put the cursor, that's gonna be the pivot point. Now, median point, okay, is the point between both objects or more objects. So if I have more objects and select all of them, the median point is going to be a point in between all of these cubes. So mathematical center between all of them, right? Now, active element here, the last one, If I select this cube last, so select this one first, hold shift and this one, and I start rotating, they both will rotate around the origin point of this active object, which is the last cube selected, right? Now the bounding box really depends on, it's quite abstract because it's a bounding box. Okay, imagine that there is a, you have these two cubes and you wrap them around in another cube. You know what? I have an idea how to show it to you. So let me create a cube, right? Kind of like this, and I'm going to bring it down a little bit and make it a little bit smaller, like this, a bit smaller, okay, something like this, and make it a bit more narrower, and on this axis as well. So you see that. Now let me change it to a different material, so I'm gonna make it into glass, okay? Now that's a bounding box. A bounding box will fit both of these objects inside of it, okay? So these two cubes, right, inside, will rotate around the center of the bounding box. And if you select one cube, you're gonna do the same thing, okay? So that's the bounding box pivot point. And that's all you need to know about pivot points. Thanks for watching. Hi guys, Ryu here, and let's talk about shortcuts in Blender. I'll give you the most useful and most commonly applied shortcuts in Blender because it's simply impossible to give you all of them. It's just too many. So let's talk about the basics. Shift A to add stuff to your scene. So cube, circle, empty, whatever you want, text. It's Shift A. Everything is under here. Curves, all that stuff, right? So let's add a cube. Now movement is G. You press G and you simply move your mouse, rotate R and scale S, right? Duplicating object, Shift D or Alt D, depending on what you want to do. Alt D is simply linking both objects together. So if I go to edit mode and apply the changes, like here you see, they're all linked together. And when you do a Shift D, a duplication, they're not linked together. So that's that. If you want to select everything, you press A, X to delete, okay? So if you have multiple objects, right, you can select them with A and deselect them with pressing A twice. Now in edit mode, if you want to select one object, you click on it. If you want to select two, you simply hold shift and click. So just like in Windows, X and delete. Now if you want to go to an edit mode, you simply have to press tab and then you have to choose between 1, 2, 3. So 1, 2, 3 in Blender gonna bring you to vertex, edge or face orientation. However, I'm using machine tools, so my shortcuts are different. I simply move my mouse and that's it. I don't need any shortcuts and it's much quicker. Now in edit mode, I for inset, E for extrude, S for scale, R for rotate, G to move. Then you have a Control B to bevel an edge and Control Shift B to bevel a vert. And I think this should cover that. Okay, another shortcut that's important, which is Alt A. So after you scale something in object mode, Alt A to apply, for example, rotation scale, but usually we apply scale. So then, for example, stuff like bevels can work properly, because without applying this scale, right, bevel's gonna look weird. Let me show you. See what I mean? So when you apply scale, it works as intended. Now camera movements, right? So camera movements, when you hold middle button, you move your camera, you sort of rotate it, then scroll wheel or control and hold middle mouse button and move up and down, or shift and pan with a middle mouse button pressed. So these would be the main movement shortcuts. N would be for end panel on the right side, T would be for the left hand side panel. These are quite important. Another important shortcut that you should definitely know of is Alt-Z, which is basically going back in time. So let's say I bevel this and rotate it, right? But I don't like it, so if I press Alt-Z twice, I'm gonna go back to the cube state. So simply revert what you've done. You can set up the amount of steps of history in under system. Yes, here, undo steps. So you can set it up. Another very useful shortcut would be H. So H will hide stuff in your scene, and Alt H would bring it back. / will bring stuff to local view, and / again will bring you back to the main scene. This is very useful when you want to do some strategic editing. So you bring it to local view and then you bring it back. The same with hiding. And you can do hiding, you can hide stuff in edit mode as well. So you can hide it, and then Alt H to reveal it. It's just like masking in Photoshop, similar thing. Another useful shortcut that you might want to know is M. So when you have something selected and you press M, you can add this object to a new collection. Let's type it new. And if I click OK, you can see that a new collection was created with this cube in it. So now I can actually turn off the whole collection. So this is really useful when you want to organize your stuff in your scene. And then you can simply press M and choose a collection you want to bring that object to. That's very useful. Then you have movement on the axis. So I told you that you can move stuff with G, but if you press G and Z, you're gonna move it on Z axis. Then when you press Y, it's on Y, and X is on X. However, if the object is rotated, right, to quickly access this local axis, you press G, Z, and Z once more, and then you have orientation on local axis. So this would be X, and this would be Y, so YY. Alternately, if you want to move something really quickly, you can simply do it with a mouse. So G, and simply hold your middle mouse button and move along whichever axis you want. So this X, like for example GZ or GY, and if you release this, it's gonna get locked to an axis. But if you hold your button again, by moving your mouse, you can decide which axis you want to move it on. That's also quite useful. The last shortcut I'll show you is parenting, which is a little bit more advanced, and let me show you how it works. So if I click on this cube and press Ctrl P, I can set parent to this object and keep transformation. I'm going to have this line selected here, you see. So now this object is a parent, and if I move it, this one will move with it. So whatever I do with this object, you see, this one will move. This is extremely useful when you, for example, have a cluster of objects, right? So let's duplicate this cube, okay? And you see the parenting has been duplicated as well, right? So this has been duplicated, and I have all these, small objects. Let's say I want to change material on all of them, right? All I need to do is click on Shift G and then select children, right? And I can change material on all of them, or for example, I don't know, rotate them or do whatever I want. Very convenient shortcut. This is a bit more advanced use, but I just wanted to show you that you can do a lot of cool stuff with shortcuts. That should cover the basics of the shortcuts in Blender. Thanks for watching. Hi guys, Ryu here, and I want to talk to you about transform orientations. Now, globe orientation is the most basic one, which is Z, Y, and X. Local orientation, the next one, is an orientation of an object that's been rotated. So that would be local orientation. The Z-axis shifted to the right because the object was rotated. So you can access local orientation from global orientation by simply pressing Z twice. So G, Z, Z, or XX and YY, right? So G, Z, that's global, another Z, that's local. Now, normal orientation is basically orientation aligned that aligns to the orientation of the normals of faces. So if I switch it on, you can see these lines, right? That's the normal orientation. So each of these faces is gonna have a different orientation, right, according to these normals. So if I move this face on a normal orientation, that's gonna be kind of similar to local in this case. Okay, next one, gimbal. I'll be honest with you, I never use gimbal orientation. It's basically a free rotation. So if you want to free rotate your object without any constraints to an axis, you just simply press R twice and you can do whatever you want with it now. It's a free rotation, okay? Now, view rotation, it's actually aligning to your view. So however you adjust your camera, okay, the view, right, you will be rotating according to view. It's a little bit confusing, and you know, you need to sort of play with it to understand how it works. I never use view orientation in my workflow. I just find it too annoying, to be honest. But it's there if you need it. And cursor orientation, well, if you look at the cursor, right, the cursor has like kind of like lines, like a cross inside, right? So now, depending on the orientation of these lines, you see, that's how the transformation orientation is going to work. So again, depending how those lines are positioned, right, the lines of the cursor, you see, it's very difficult to see because if you zoom, it doesn't work really. So the black lines here, that's the cursor orientation. So you see, it's going to move along these lines, okay, of this crosshair. And that's cursor orientation. And to be honest, I don't use it either. Orientation I do use a lot is a custom orientation, and that one is actually quite hidden. So if you rotate an object and apply a rotation of this object, right, the rotation of this object will reset. And what I mean by that is that if you go to item info, the rotation was reset to 0 degrees. So this object global and local orientation are the same. You see, if I press Z twice, it doesn't do anything, okay? However, if you would like to move this object along, you know, one of these faces, you might want to go here and click on that plus. And that will allow you to use a custom orientation and create sort of like a quasi-local orientation for this object, because now it will move along this face orientation. So it's like a normal orientation, but for the entire object, okay? So that's the custom orientation. And if you press Z once more, gonna reset to global. So global and custom. And that covers transformation orientation in Blender. Thanks for watching. Hi guys, Ryu here, and let's talk about windows in Blender. Now, windows in Blender are just workspaces, right? And you can just, you know, move them about, make them smaller, bigger, and so on. However, you can also drag new spaces, workspaces, into your canvas like this. So when you hover your mouse in a corner, you just simply click and drag, and you can hover it back and drag it down. You'll see this arrow, and you can drag it in any direction, okay? Sometimes a bit fiddly, you see. There we go. Now, the cool trick I want to show you, if you work on a multi-monitor system, if you hold shift and do this, right, you're gonna have a new separate window. So now what you can do is simply grab this one and put it on a different monitor. This is how I like to work. So I can basically have another window and I have it split into, for example, shader editor when I have my, let's say, nodes with materials or my AGRI. And here, for example, I got a timeline, let's say, okay? And I work on my animation or whatnot. And you just simply close it if you want to close it, right? Additionally, if you're going to open some window as such, or detach it, as I showed you with shift, right? So hold shift and command window. There we go. Detach it with shift, and then you will go here and save preferences. So default startup file. When the Blender opens, it will open with that window open. So you can customize your workspace this way. And this goes to every single window in Blender, so you can customize all of these, right, to your liking. And then you can just go ahead and save your startup file, and when Blender opens, you're gonna have your workspace ready to go. Thanks for watching. Hi guys, we're here and let's talk about empties. Empties are simply coordinate points. They do not have any volume, any faces, verts, they just exist and they cannot be rendered, so they're literally invisible in renders. So here you have access to empties. You can select and create different kind of empties and different shapes. Let's grab this one. So how do you use it? Well, you could, for example, mirror across an empty. So if you have a cube and you, let's say, move it in here, you grab an empty and you could flip it across, right? You could assign or parent an object to an empty, like for example a camera. So if I'm gonna go to my machine tools and grab a camera, let's move it a little bit here like that, okay, and then I assign it to an empty. So I have camera selected, I click on empty, I click Ctrl P and object keep transform. So now if I move or do anything with this empty, the camera will move with it, and so will the cube. So you could use it, for example, for animations and stuff. And I can see there's a parent line between the camera and the empty. So whenever I move it or scale it, things will happen, right? Or for example, rotate it. That's how the turntable camera works in Hard-Ops, for example. Another example I could show you, let's grab a cube, right? And let's slice it with, actually, you know what? Let's just simply divide it like this. Shift D to copy it like that. And let's select this top cube, select this edge and move cursor in here. Now if I create anything, it's going to be created on the cursor, you see. Now if I parent this cube to this empty, so Ctrl P and keep object transform, now if I actually rotate it, right, on x-axis, you see I can create some kind of animation of a case or crate opening. So these would be the most common uses of empties, and that's how I use them on a daily basis. Thanks for watching. Hi guys, Ru here, and let's talk about curves. Curves can be very powerful if you know how to use them. I use them a lot for cables, pipes, all kinds of stuff. So let's talk about the basics, right? If you go to your curve menu, and by the way, my curve menu is larger because I have this add-on enabled, extra curve objects. So if you go to curves, Shift A, right, and then Bezier curve, the most basic one, and go to edit mode, you'll see these handles. Now they behave very much like handles of a pen tool in Photoshop. So you can simply move them, you can use R to rotate them, so G or R, and you can manipulate with them, you can extrude them, you can do all kinds of stuff. So let's do something like this and Ctrl A to apply scale. So what I want to do now is change it into a pipe. All you need to do is go here to this tab and then change bevel depth, and you're done. On top of it, you could actually add Ctrl 1, so add the subdivision modifier to it by pressing Ctrl 1. Now this is still a curve, not a mesh, so if you want to change it to mesh, you need to go to Alt A and Visual Geometry to Mesh, or go to Object and convert mesh from curve. Now the problem is that we have a modifier going on it, and if I actually apply this, you'll see that the modification is going to be applied with it. If you want to avoid this, I would suggest go back a little bit and remove this first, right? Then apply this geometry transformation and then add modifier on top of it, which means you have a live modifier going on this pipe. The problem with this is that you can't really do anything much more with it because it's baked into Geo. Now the advantage of doing it with Hard-Ops is that if I, let's say, delete this vert really quickly and Shift Ctrl B to bevel these and go to operations and curve extract, I can press 1S to smooth it and Control 1 after applying, right? And now this is a curve, okay? So I can still adjust it, right? You can see it's a curve inside. It's not a mesh, it's a curve. However, if I press, if I go to curve again and press X, it will revert back to just a curve. And now I can convert it, select it and convert it to mesh, and I'm back into vert mode. So this is actually quite a powerful way of working. In addition, you have two of them because this tool extracts from the edge and creates a curve, so you have like a backup mesh to work with, right? Now let's stay with this one and do something cool. So if I wanted to, let's say, create an array of items that will follow the curve, right? So I will just go ahead and add a cube, and that's my cube. And then I would reshape it. You know what? Let's actually make it smaller, so it's going to be cooler. And let's reshape it, so maybe extrude it and inside it extrude it, something like this. That's cool, something simple. And maybe, you know what, let's just bevel it because it's just too squarish. I don't like it. Let's make it into a cable-ish sort of, you know, so just bevel it, kind of looks cool. And add some maybe tiny bevel on it. All right, so now we're going to array this, right, like that. That's enough. And now we want to do is apply this one to follow that one, right? So what we're going to do is go to Hard-Obs and select this curve and the mesh and click on this curve here. And this will align it. Now the problem here is that we need to do some changes in the curve settings. So let's change the orientation of this to something else. Let's try maybe -Z. Nope, maybe -X. Sometimes it's just a bit of a fiddling with axes. So if you now press G and X to move it on X, it will actually follow this curve, you see? So it's a pretty cool way of working. Now, the powerful thing about it is that, and if I wanted to make it more detailed, you just simply, you know, play with extrusion, right? And you could just make it a little bit longer, like that. And then this item will keep on following this curve if you make it longer. Now, the item that follows the curve is going to get distorted. That's normal, but you could actually help it a little bit by subdividing it. So in Hard-Obs, what I would do personally is, you know, simply run maybe dice through it, right? So go to dice and simply run dice over it, right? If it's really large. In this case, I don't think it's necessary, but it's always going to help a little bit with bending and curving, especially if the object is really long. If you don't have Hard-Obs and you want to do it manually, you need to select the object, go to modifier and click on curve. Then you have to go to settings and simply choose an object that you want to deform. So in case this one, right? So we're deforming this one along the curve. I think that should got you covered in terms of basic stuff regarding curves. Thanks for watching.